Hey everybody, my name is Ian Gaffney, and today we're going to revisit the charge tapes lab. So the purpose of this lab is we want to computationally figure out what the total charge on the top piece of tape is using our experimental data from lab number one. The system in this lab is the top piece of tape, and the surroundings is everything else, including the earth and the bottom piece of tape. The initial conditions are the top piece of tape is at rest, and the only force acting on it is gravity. So the physics concepts I use in this lab were mainly the force of gravity and the electric force, um, and by extension, I also use the electric field. And then since we basically had a bunch of point charges lined up next to each other to represent the tape, I did electric field supercomposition or superposition, um, and by extension, also the electric field of a rod, which is more general to state what the tape was in this lab. Um, so the actual experiment was the same experiment from lab one, where I suspended a charged tape and then brought another charged tape under it, and basically the repulsion force made it raise the top one raise up a little bit until it reached equilibrium with gravity, and from there I could figure out what the charge on the tape was due to the distance that I found. Um, so the important figures we need to keep track of are the mass of the tape was 0.00018 kilograms. The charge on the tape was 3.1 times 10 to the negative eighth coulombs, and the separation of tapes at equilibrium was 2 centimeters or zero point zero 0.02 meters. So here's a new model I made for this lab where I treated the tape as a bunch of different point charges lined up next to each other. So this is the main function up here that we need to pay attention to. Um, so basically, we I basically stated that there are in point charges in the two tapes, and I went through and for each point charge on the bottom tape, I then calculated in another loop, um, basically what its electric field would be on every single one of the top charges, and I did that every single time. So this whole function ran n times n times, um, and it would find the total electric force on each of the top charge, so the top point charges, and then I summed them up to get the total electric force from the bottom tape to the top tape, and then I also had gravity as well and compared the two. So here's the results. All these little green arrows are each is just like the electric force vectors that are acting on the top point particles. It's hard to see because of the scale, but um, that little blue line is the bottom one, and then above that there's a red line, and that's the top one, and the green arrows are coming from the top one. This white arrow is the total electric force, and the yellow arrow is the force of gravity. And then here's the figures we got. So the magnitude of the electric force is 1.76976 times 10 to the negative 3 newtons. And then it's pretty close to the gravitational force, which means our model is pretty good. So the analysis, the magnitude of the charge on which piece of tape was, which after doing some math, I found there was 3.906 times 10 to the negative ninth coulombs. Um, and then the assumptions, approximations, and idealizations I made, where I ignored air resistance on the moving tape, and I assumed the ECU tape had the same amount of charge evenly distributed along the length of the tape. So what if I'd model each of my tapes as a single point charge? Well, we already did that in lab one, and I got the value of 8.86 times 10 to the negative ninth coulombs, as compared to my new value of 2.804 times 10 to the negative eighth coulombs, which is a lot closer to the actual value of 3.1 times 10 to the negative eighth coulombs. Why are these two estimates different from each lab? So in the first lab, I treated the entire piece of tape as one point charge in the middle, whereas in this lab, I had n number of point charges along the entire tape to represent it. So it's going to be a lot more accurate to what is actually happening in real life, because the electric force is not just acting on the middle of the tape in real life, it's acting on every single little part of the tape. And so having all of those summed up is going to be a little bit of a closer answer than just having one point to approximate it. Thank you. That's all I have today.